Welcome back to another math lesson hosted by Book&Table. I am your math tutor, Maurice Wright, and in this chapter we are going to review 2x2 systems. You'll learn how to find the solution to 2x2 systems by using the substitution and elimination methods. You'll also learn how to find the solutions to a system of inequalities by graphing the systems. Should you have any follow-up questions, feel free to leave them in the comments section, or you can contact a tutor in your neighborhood by visiting bookandtable.com or by downloading our app on the App Store. So let's kick off the chapter by discussing linear systems. A linear system of two equations with two variables is any system that can be written in the form ax plus by is equal to c, dx plus ey is equal to f. So we have two equations, each with two different variables, x and y, the same two variables in both equations. A, b, d, and e are the coefficients of our variables. And we see these expressions are equal to these numerical values being represented by these variables c and f. So we'll use both equations using the substitution and/or the elimination method, depending on the question, to find the value of the x and the y in these equations. And x will have the same value in both, as well as y. Now, a linear equation can include coefficients with a value of 0 as long as one variable is present in the equation. So 3x plus 2y is equal to 5 is a linear equation. We have our x and our y. Both have a coefficient here, 3 and 2, so that's fine. X plus 0y is equal to 7 is also fine. This would be x is equal to 7. So as long as you have one of the two variables present, then you're all set. Nonlinear systems, these are the types of expressions you won't see in this chapter. A linear equation can only have variables that each have an exponent equal to 1. So here we have 3 plus 2 is equal to 5, so we don't have at least one of our variables. So this would not be a linear system. X squared minus 2y is equal to 3. Here, our variable x has an exponent of 2, so this is not a linear system either. So throughout this chapter, our x's and y's will only have an exponent equal to 1. Now, 2x2 systems. A 2x2 system of equations is a set of two equations with two unknown variables. The solution to this system is the xy value that solves both equations. So for example, x plus y is equal to 5 and 2x minus 3y is equal to 10 is an example of a 2x2 system. We have two equations and they each have the same two variables, x and y. And the solution is when x is equal to 5 and y is equal to 0. In this case, 5 plus 0 is equal to 5, so the first equation checks out. And in the second equation, when x is 5, we get 2 times 5, which is 10, minus 3 times 0, our y. So we get 10 minus 0, which is equal to 10. So the x is equal to 5 and the y is equal to 0, winds up making both equations true, and thus 5, 0 is the xy value that solves this system. A solution to a system of equations is the point, the xy coordinate, where the two lines intersect. So we're working with lines, linear equations. The xy is the exact point that works for both lines. This is the point in space where both lines exist, and thus both linear equations work. So in essence, this is what you are finding by solving a 2x2 system. Now, not every 2x2 system has a solution. If a system of equations has two lines with the same slope but are not the same, then there is no solution. So if two lines have the same slope, but they cross the y-axis at 2 different points, then that will let you know that the lines do not cross. And if this is the case, then there will not be a solution. There's no xy point where they both exist. So when you have a 2 by 2 system, how do you know when this is the case? Well, the system of equations for parallel lines will produce a false statement during the substitution or elimination method. We'll take a look at the substitution and elimination methods in a second, but as you are using them, you'll wind up with a statement such as 0 is equal to 10, 2 is equal to 14, 5 is equal to -3, or something along those lines. When you wind up with a statement that is not true, that is a signal that there is no solution to the 2 by 2 system that you were given. Now, a different example is when there are infinite solutions. If a system of equations has 2 lines that are the same, then there are an infinite number of solutions. That is because at every single point, both lines exist because they are the same line. So when you have your 2 by 2 system, you'll know that you have infinite solutions when you wind up with a true statement, such as 0 is equal to 0, 10 is equal to 10, 7 is equal to 7. So remember, the system of equations for 2 identical lines will produce a true statement during the substitution or elimination method. So keep those in mind, and now we can jump into the substitution method. The substitution method is the process of solving one equation for one variable and then substituting this number or expression into the second equation to solve for the second variable. So let's start off with this example. Let's say we had the 2 by 2 system, y is equal to 3 and -4x plus 2y is equal to 9. We won't need to solve the first equation for a variable since it is the solution for one of our variables. So if you wanted to solve for x in the second equation, you would plug y is equal to 3 here, and now you'd be able to solve for x. Let's say you were given x is equal to 5, and the second equation is -4x plus 7y is equal to 15. You would plug 5 in for x, and then you would solve for y. So that is how you would use the substitution method to solve for the second variable when one of the equations provides you the value of the first variable. But let's now walk through an example of a 2 by 2 system in which both equations have 2 variables. So solve by substitution and check the answer. Equation A, x plus y is equal to 9. Equation B, 2x minus 3y is equal to -7. So we want to use the substitution method to solve for both x and y. So what we'll do is, we'll first use equation A to isolate x or y. This will give us an equation, not a numerical value, but we can then substitute that expression into equation B for x or y, whichever one we solve for, and then we can solve for the second variable. Now throughout this chapter, what I'll do is, if x and y have the same coefficient, whether it's 1 or another number, then I'll solve for x. I'll only solve for y first if y has a coefficient of 1 and x has a coefficient of another value. Because in that case, y would just be easier to find. Otherwise, I'll just solve for x and substitute x into equation B to solve for y. Just so you can complete the questions with the same process, so when I go over it, it's closer to what you did. Okay, remember you can solve equation A for either x or y, but I'll be solving for x when they both have the same coefficient. Okay, so let's go back to this question. So step 1, isolate x on the left side of equation A. So we'll take x plus y is equal to 9, and we'll isolate x. So that means we'll subtract y from both sides, giving us x is equal to -y plus 9. This is positive 9. So now we'll take this expression, and step 2, we'll substitute x into equation B here, giving us 2 times negative y plus 9 minus 3y is equal to negative 7. And now we'll distribute this 2 to both terms inside the parentheses here, giving us 2 times negative y, which is negative 2y, and 2 times positive 9 is positive 18, minus 3y is equal to negative 7. Since these variables have the same exponent, we can combine them. So negative 2y minus 3y is negative 5y. So we wind up with 18 minus 5y is equal to negative 7. And now we can solve for y. So we'll first subtract 18 from both sides to get rid of this constant, giving you negative 5y is equal to negative 7 minus 18 is equal to negative 25. So we get negative 5y is equal to negative 25. And now to get rid of this coefficient of negative 5, we'll divide both sides by negative 5, giving us y is equal to negative 25 divided by negative 5, which is 5. So now that we have a value for y, we can now substitute y into equation A. This was equation B. So step 4, we'll plug y into equation A. And then step 5, we'll solve for x. So x plus 5 is equal to 9. So we'll subtract 5 from both sides, giving us x is equal to 9 minus 5, which is 4. So using the substitution method, we find that x is equal to 4 and y is equal to 5. So that is the solution to the 2x2 system. And step 6, to check the answer, you want to plug the xy, 4, 5, into the original equations to confirm that this is true. So when you plug x is equal to 4 and y is equal to 5 into equation A, we get 4 plus 5 is equal to 9. 9 is equal to 9 confirms that these are the xy values for equation A. And now for equation B, 2x minus 3y is equal to negative 7. 2 times 4 is equal to 8. Negative 3 times 5 is negative 15. 8 minus 15 is equal to negative 7. Negative 7 is equal to negative 7 confirms that x is equal to 4 and y is equal to 5 for equation B as well. So that is how you go about solving a system with the substitution method. Let's now have you complete a few practice questions. Solve by substitution and check the answer. Question number 1. Equation A, negative 3x minus 3y is equal to 3. And equation B, 5x plus y is equal to negative 17. Question number 2. Equation A, 2x plus y is equal to 20. Equation B, 6x minus 5y is equal to 12. Question number 3. Equation A, negative 2x plus 6y is equal to 6. And equation B, negative 7x plus 8y is equal to negative 5. Pause the video, answer these questions, and then press play when you are ready to begin. Question number 1, step 1, isolate x on the left side of equation A. So equation A, we have negative 3x minus 3y is equal to 3. So we'll isolate x. So we'll start off by adding 3y to both sides, giving us negative 3x is equal to 3y plus 3. And now to get rid of this coefficient of negative 3, we'll divide both sides by negative 3, giving us x is equal to 3y divided by negative 3 would give us negative y, since the 3's would cancel out. Positive 3 divided by negative 3 is negative 1. So we get x is equal to negative y minus 1. And now we can take this expression and substitute x into equation b here. So we get 5 times negative y minus 1 plus y is equal to negative 17. You now want to distribute this 5 to both terms inside the parentheses, giving us 5 times negative y, which is negative 5y. And 5 times negative 1 is negative 5. Plus y is equal to negative 17. You want to combine the like terms. Negative 5y plus y would give you negative 4y. So we wind up with negative 5 minus 4y is equal to negative 17. And we can solve for y now. So we'll add 5 to both sides to get rid of the negative 5. So we get negative 4y is equal to negative 17 plus 5, which is negative 12. And now to get rid of the coefficient negative 4, we divide both sides by negative 4, giving you y is equal to negative 12 divided by negative 4, which is positive 3. So now that we've solved for y, step 4, we want to substitute y into the other equation, equation A. So we'll plug it in here, and then step 5, we'll solve for x, giving us negative 3x minus 3 times 3 is equal to 3. Negative 3 times 3 is equal to negative 9. We'll now add 9 to both sides to get rid of negative 9 on this side, giving us negative 3x is equal to 3 plus 9, which is 12. In order to get rid of the coefficient, negative 3, we'll divide both sides by negative 3, giving us x is equal to 12 divided by negative 3, which is negative 4. So the solution is x is negative 4 and y is positive 3. In step 6, we can check the answer by plugging the xy, negative 4, 3, into the original equations. When we do so, we get negative 3 times negative 4 is 12, minus 3 times 3, which is 9. 12 minus 9 is equal to 3, and that's equal to 3. So for equation A, x is equal to negative 4 and y is equal to 3 checks out. And for equation B, 5x plus y is equal to negative 17. 5 times negative 4 is negative 20, plus 3. Negative 20 plus 3 is negative 17. So this confirms that for equation B, x is equal to negative 4 and y is equal to 3 as well. So that is the solution to question number 1. Let's now have a look at question number 2. We had equation A is 2x plus y is equal to 20, and equation B is 6x minus 5y is equal to 12. Since the coefficient of y here is 1, it's easier to solve equation A for y. So we'll isolate y on the left side of equation A for step 1. So we'll subtract 2x from both sides, giving us y is equal to negative 2x plus 20. And now step 2, we'll substitute y into equation B here. And then step 3, we'll solve for x. When we do so, we get 6x minus 5y, which is minus 5 times negative 2x plus 20 is equal to 12. When we distribute the negative 5, we get negative 5 times negative 2x, which is positive 10x. Negative 5 times 20 is negative 100, and that's equal to 12. We can combine the like terms. 6x plus 10x would give us 16x. Minus 100 is equal to 12. Now we'll add 100 to both sides. giving us 16x is equal to 12 plus 100, which is 112. And now to solve for x, we want to get rid of this coefficient of 16. So we'll divide both sides by 16. So that would give us x is equal to 112 divided by 16, which is 7. And now that we've solved for x, we can now solve for y. So we'll substitute x into equation A here. And then step 5, we'll solve for y. So 2 times 7 is equal to 14, plus y is equal to 20. And to isolate y, we'll subtract 14 from both sides, giving us y is equal to 20 minus 14, which is equal to 6. So for question number 2, we get x is equal to 7 and y is equal to 6. And to check this answer, step 6, we could plug it into both of the original equations to confirm that x does equal 7 and y does equal 6 for both. So for equation A, 2 times 7 is 14, plus 6 would give you 20 is equal to 20. And for equation B, 6 times 7 is equal to 42, minus 5 times 6, which is equal to negative 30. 42 minus 30 is equal to 12, thus confirming that x is equal to 7 and y is equal to 6 for both equations. In question number 3, we were given equation A, negative 2x plus 6y is equal to 6, and equation B, negative 7x plus 8y is equal to negative 5. So we'll start with equation A, and we'll isolate x on the left side. So in order to do so, we'll subtract 6y from both sides, giving us negative 2x is equal to negative 6y plus 6. To get rid of the coefficient, negative 2, we'll divide both sides by negative 2, giving us x is equal to negative 6y divided by negative 2 would be 3y. Positive 6 divided by negative 2 would be negative 3. So we get x is equal to 3y minus 3. And now step 2, we want to substitute this expression for x into equation B here. And then step 3, we can then solve for y, giving us negative 7 times x, which is negative 7 times 3y minus 3, plus 8y is equal to negative 5. Negative 7 times 3y would be equal to negative 21y. And negative 7 times negative 3 would be positive 21. Plus 8y is equal to negative 5. We can combine the like terms, negative 21y and positive 8y, which would give us negative 13y. And now we can solve for y. So we'll subtract 21 from both sides, giving us negative 13y is equal to negative 5 minus 21, which is negative 26. And now to solve for y, we'll divide both sides by negative 13, giving us y is equal to negative 26 divided by negative 13, which is equal to 2. So now that we have a value for y, we can substitute y into equation A and then solve for x, giving us negative 2x plus 6 times 2, which is equal to 6. 6 times 2 is equal to 12. So we'll subtract 12 from both sides to get rid of positive 12 on this side, leaving us with negative 2x is equal to 6 minus 12, which is negative 6. In order to get rid of this coefficient of negative 2, we'll divide both sides by negative 2. When we do so, we get x is equal to negative 6 divided by negative 2, which is positive 3. So the solution to question number 3 is x is equal to 3 and y is equal to 2. In step 6, we can check the answer by plugging the xy into the original equations. When we do so, we get negative 2 times 3, which is negative 6, plus 6 times 2, which is 12. Negative 6 plus 12 is equal to positive 6, which is equal to 6, thus confirming that x is equal to 3 and y is equal to 2 are the correct values for equation A. And for equation B, negative 7 times 3 is negative 21, plus 8 times 2, which is positive 16. Negative 21 plus 16 is equal to negative 5, and that's equal to negative 5. Thus confirming that x is equal to 3 and y is equal to 2 is the solution to this 2 by 2 system. So that is how you would go about solving 2 by 2 systems using the substitution method. Let's now discuss how you would go about solving 2 by 2 systems using the elimination method. Now, the elimination method is the process of solving for one variable by combining the two equations by addition or subtraction. So let's say you were given the 2 by 2 system, x minus y is equal to negative 6, and x plus y is equal to 8. Instead of isolating x or y in the first equation, and then plugging that expression into the second equation to solve for the second variable, instead, we'll be adding or subtracting the two equations, and by doing so, the aim is to eliminate one of the two variables. So just like the substitution method, there is a bit of flexibility here. You can choose to eliminate x or y first to solve for the first variable. So here, since the x's have the same coefficient, positive 1, you'll want to use subtraction since x minus x would be 0, thus eliminating the x and leaving you with just y. Negative y minus y would give you negative 2y. Negative 6 minus positive 8 would give you negative 14. So by subtracting the second equation from the first equation, we got rid of the variable x, and now from here we can solve for y. But instead of subtraction to get rid of our variable x, you could also choose to eliminate the y here, since the coefficient of y in the first equation is negative 1, and the coefficient of the y in the second equation is positive 1. Y can be eliminated by adding them together, since negative 1 plus 1 is equal to 0, thus leaving you with x plus x, which is 2x. Negative 6 plus 8 will give you positive 2, and from here you can solve for x. Now, one thing to note, you can be given a 2 by 2 system in which the coefficients of your variables are different in the two equations. So how would you use the elimination method here? Since adding or subtracting the two equations as they are written will not actually get rid of either variable. In this case, one equation can be multiplied on both sides in order to make the coefficients of one of the variables equal but with opposite signs. So we have x plus 2y is equal to negative 2, and negative 2x plus y is equal to negative 11. If we were to subtract our x's here, it wouldn't get rid of the x. If you subtract the y's here, it wouldn't get rid of the y's. If you add the x's, it wouldn't eliminate the x's. Positive 1 minus 2 would give you negative x. If you add the y's, 2y plus y would give you 3y, so that wouldn't be eliminated either. So when we multiply this equation by negative 2, we get negative 2 times negative 2x, which is positive 4x. Negative 2 times y is negative 2y. And negative 2 times negative 11 is positive 22. And now that we've done that, with positive 2y and negative 2y, we can eliminate our y variable by adding the two equations together. So you get x plus 4x is equal to 5x. Negative 2 plus 22 is positive 20. And our y's are eliminated because positive 2y minus 2y is equal to 0. So now we can solve for x from here. Okay, so there's flexibility. You can choose which variable you eliminate first. You can choose which equation you'll be multiplying times a constant to make the coefficients work like we did here. Let me just clarify from now how I'll be solving these questions in this chapter so it makes it easier for you to follow along. What we'll want to do is we'll want to eliminate x first and solve for y unless the coefficients of the y terms are equal or equal with opposite signs. Okay, so in this case, if you were given this 2 by 2 system, negative 4x plus y is equal to negative 19, and 2x minus y is equal to 11. Rather than multiply this equation times 2 so that we can cancel out our x's, we can skip that step since the coefficients of our y's are equal with opposite signs, positive 1 and negative 1. So we can eliminate the y's by adding these equations. So in this case, you would eliminate y first. Let's say you were given this 2 by 2 system instead. Negative 4x minus 3y is equal to negative 7. And 2x minus y is equal to 11. No matter which variable we want to solve for first, we'll have to multiply one of the equations by a constant in order to make the coefficients work. So whenever this is the case, we'll be eliminating x first. Okay, so I just want to clarify so that it makes it easier for you to follow the practice questions that we're doing, so that when you go over it, my explanations line up with yours, since there are different pathways you could take to get to the same answer. But let's now walk through an example together to solve a 2 by 2 system using the elimination method. So solve by elimination and check the answer. Equation A, 2x minus 9y is equal to 8. And equation B, negative 5x plus 8y is equal to negative 20. So since neither variables have coefficients that are equal or equal with opposite signs, we'll want to eliminate x first and solve for y. So we'll want to multiply equation A times positive 5 so that we get 10x. And we'll want to multiply equation B by 2 so that we get negative 10x. When we do so, 5 times 2x is 10x. 5 times negative 9y is negative 45y. And 5 times 8 is equal to 40. And for equation B, 2 times negative 5x is equal to negative 10x. 2 times 8y is 16y. And 2 times negative 20 is negative 40. So now the coefficients of our x terms are equal with opposite signs. So we can eliminate x by adding the two equations together. So that's step 3. When we do so, we get negative 45y plus 16y, which is negative 29y. And 40 plus negative 40 would be equal to 0. So now that we've eliminated x, step 4, we can solve for y. So we want to get rid of this coefficient, negative 29, in order to solve for y. So we divide both sides by negative 29, giving us y is equal to 0 divided by negative 29, which is 0. And now that we've solved for y, step 5, we can substitute y into either equation A or B. And then step 6, solve for x. So I'll show you that it works for both. 2x minus 9 times 0 would be 2x minus 0 is equal to 8. So 2x is equal to 8. We divide both sides by 2, and we get x is equal to 8 divided by 2, which is 4. If you were to plug in y is equal to 0 into equation B instead, you would get x is equal to 4 also. So negative 5x plus 8 times 0 is equal to negative 20. 8 times 0 is 0, so you get negative 5x is equal to negative 20. Divide both sides by negative 5, and you get x is equal to negative 20 divided by negative 5, which again is x is equal to 4. So the solution to this problem would be x is equal to 4 and y is equal to 0. And now you can check the answer by plugging the xy into the original equations. to confirm that x is equal to 4 and y is equal to 0 in both equations. So starting with equation A, 2 times 4 is equal to 8, minus 9 times 0, which is 0, is equal to 8. 8 is equal to 8 confirms that for equation A, x does equal 4 and y does equal 0. And for equation B, negative 5 times 4 is negative 20. 8 times 0 is 0. So we get negative 20 is equal to negative 20, which is true, thus confirming that x is equal to 4 and y is equal to 0 is the solution to both equations. So that is how you would go about solving a system with the elimination method. Let's now have you complete a few practice questions. Solve by elimination and check the answer. Question number 1, equation A, 9x minus 4y is equal to 30. Equation B, 7x plus 4y is equal to 2. Question number 2, equation A, 8x plus 2y is equal to 12. Equation B, negative 6x plus 3y is equal to 9. In question 3, equation A, 2x plus 8y is equal to 6. In equation B, negative 5x minus 20y is equal to negative 15. Pause the video, answer these questions, and then press play when you are ready to begin. Question number 1. Since our y terms have coefficients that are equal with opposite signs, we'll eliminate y first, since we can do so by adding the equations together. Negative 4 plus 4 would be 0, so that would allow us to eliminate y, leaving us with 9x plus 7x, which is 16x, and 30 plus 2, which is 32. So now that we've eliminated y, step 2, we could solve for x. So we want to get rid of the coefficient 16. So we divide both sides by 16, giving us x is equal to 32 divided by 16, which would be equal to 2. So now that we have x is equal to 2, we want to substitute x into either equation A or B for step 3. When we do so, we can solve for y for step 4. So when we plug x is equal to 2 into equation A, we get 9 times 2, which is 18, minus 4y is equal to 30. We can get rid of the 18 by subtracting 18 from both sides, leaving us with negative 4y is equal to 30 minus 18, which is 12. And to get rid of the coefficient negative 4, we divide both sides by negative 4, leaving us with y is equal to 12 divided by negative 4, which would be negative 3. So we get x is equal to 2 and y is equal to negative 3. But if you plug the x into equation B instead, you would get the same y. So we get 7 times 2, which is 14, plus 4y is equal to 2. Now we want to subtract 14 from both sides, giving us 4y is equal to 2 minus 14, which is negative 12. And then to get rid of the coefficient of 4 in front of the y, we want to divide both sides by 4, leaving us with y is equal to negative 12 divided by 4, which is negative 3. So we get negative 3 if you plug x is equal to 2 into equation A or B. You'll get the same value for y. So the solution to question number 1 is x is equal to 2 and y is equal to negative 3. And step 5, check the answer by plugging 2, negative 3 into the original equations to confirm that they work for both equations. So for equation A, 9 times 2 gives you 18. minus 4 times negative 3, which is positive 12. 18 plus 12 is equal to 30, and that's equal to 30. Confirming that for equation A, x does equal 2 and y does equal negative 3. And for equation B, 7 times 2 is 14, plus 4 times negative 3, which is negative 12. 14 minus 12 is 2, and that's equal to 2. Thus confirming that x is equal to 2 and y is equal to negative 3 for both equations A and B. So that is the solution to the 2 by 2 system in question number 1. Let's now have a look at question number 2. We were given equation A, 8x plus 2y is equal to 12. And equation B, negative 6x plus 3y is equal to 9. Since the y terms do not have equal or equal with opposite signs for coefficients, we'll eliminate x first and solve for y. So we'll want to multiply equation A times 6 so that we get positive 48 for x. And we want to multiply equation B times 8 to give us negative 48x. So when we distribute the 6 to equation A, we get 6 times 8x, which is 48x. 6 times 2y is 12y. And 6 times 12 is 72. And for equation B, 8 times negative 6x would give you negative 48x. 8 times 3y is 24y. And 8 times 9 would give you 72. Now the coefficients for our x terms are equal with opposite signs. So step 3, we can add the equations together to eliminate x, and that will then allow us to solve for y. 48x plus negative 48x would be 0, so that cancels out. 12y plus 24y gives us 36y. And 72 plus 72 is equal to 144. So we get 36y is equal to 144. And to solve for y, we want to divide both sides by 36, giving us y is equal to 144 divided by 36, which would be equal to 4. And now that we've solved for y, step 5, we want to substitute y into either equation A or B, and then solve for x, giving us 8x plus 2 times 4, which would be 8, is equal to 12. To find x, we first want to get rid of 8, so we'll subtract 8 from both sides, leaving us with 8x is equal to 12 minus 8, which is 4. And now to get rid of the coefficient of 8, we'll divide both sides by 8, giving us x is equal to 4 divided by 8, which is 1/2, or 0.5 in decimal form. If you plugged y into equation B, you would get the same value for x, 1/2. Negative 6x plus 3 times 4 would be negative 6x plus 12 is equal to 9. And now we'll subtract 12 from both sides, leaving us with negative 6x is equal to 9 minus 12, which is negative 3. And to get rid of the coefficient of negative 6, we'll divide both sides by negative 6 to give us x is equal to negative 3 divided by negative 6, which is 1/2. So the solution to question number 2 is x is equal to 1/2 and y is equal to 4. And now step 7, check the answer by plugging the xy, 1/2 and 4 into the original equations to confirm that it is the solution for both. When we plug it into equation A, we get 8 times 1/2, which is 4, plus 2 times 4, which is 8. 4 plus 8 is equal to 12. 12 is equal to 12 confirms that x is equal to 1/2 and y is equal to 4 for equation A. And now for equation B, -6 times 1/2 is -3, plus 3 times 4, which is +12. -3 plus 12 is 9. 9 is equal to 9 confirms that x is equal to 1/2 and y is equal to 4 is the solution to this system. And now let's have a look at question number 3. We were given 2x plus 8y is equal to 6 for equation A. And equation B, we were given -5x minus 20y is equal to -15. So since the y terms do not instantly cancel each other out, what we'll do is we'll eliminate our x's first and then solve for y. So we have 2x and -5x. So we'll want to multiply equation A times 5 so that we get 10x. We'll want to multiply equation B times 2 so that we get -10x. And when we distribute those constants to the entire equation, we get 5 times 2x, which is 10x. 5 times 8y is 40y. And 5 times 6 is equal to 30. In equation B, we get 2 times -5x, which is -10x. 2 times -20y is -40y. And 2 times -15 is -30. So after step 2, we can eliminate x and solve for y by adding the two equations together, step 3. But when we do so, we wind up getting 0 is equal to 0, since our y terms cancel each other out. 40y plus -40y equals 0. And 30 plus -30 would also be equal to 0. So since we cannot solve for either variable, and we wind up with a true statement, that lets us know that we are dealing with the same line, and thus there are an infinite number of solutions. So the answer to question number 3 is infinite. There are infinite solutions, since these are actually the same line. So that is how you go about finding the solution to a 2x2 system of equations. Let's now discuss how you would go about finding the solutions to a 2x2 system of inequalities. Now, a system of equations has a point or an xy coordinate, such as this one, that works for both equations. So you have one equation, equation A. You have a second equation, equation B. And the solution is the point in the coordinate plane where these two lines cross. But for a system of inequalities, it is different. A system of inequalities has a region of points that can work for both inequalities. So let's say instead of equation A and equation B, we had inequality A and inequality B. Remember, for inequalities, you have greater than or less than, as well as greater than or equal to, and less than or equal to. For less than or greater than, instead of a line, you'll have a dotted line, because the points above or beneath that line will represent these solutions, but the line itself will not be included. If it is less than or equal to, or greater than or equal to, you'll use a solid line to represent that the points on that line are included in the solution set. Now, for an inequality, when you have greater than, the points above that line are the solution to that inequality. When you have less than, it is the points beneath that line. So this shaded region here represents greater than inequality A. And this shaded region here beneath inequality B represents the solutions for less than inequality B. Now, where these two areas overlap would be the area of solutions. The area of solutions for a system of inequalities is the overlap of the two individual systems. So the points above inequality A and the points below inequality B intersect here in this darker red pink region. So that would represent the area of solutions to this system. Now this coordinate plane stops here, but the solutions would continue in this direction. The area of solutions is considered open or unbounded if there are an infinite number of solutions. So since these points continue in this direction, in the positive x direction, then this system is considered open or unbounded. So in this section of the chapter, we'll walk through an example and complete a few practice questions for open or unbounded systems. And then to wrap up the chapter in the next section, we'll have a look at bounded systems. Now there will be some cases in which you will not have any solutions. If the solutions of the inequalities do not have overlapping regions, then the system will not have any solutions. So let's say you had some inequality A, and the solutions were greater than this line, then these points would represent the solutions. And for inequality B, if the solutions were less than this point, these points would represent the solution to inequality B. So since these two regions do not overlap, the system for the two inequalities will not have any solutions. Remember, these solutions are the overlapping area between the two inequalities. But if the areas do not overlap each other, then there are no solutions. Now, as you're going through the process of using the substitution and elimination methods to find the area of solutions for a system of inequalities, you may encounter a false statement. Just like a 2x2 system of equations, if a false statement is produced during the substitution or elimination method, then there is no solution to the system. So keep an eye out for statements such as 0 is equal to 9, 1 is equal to 4, 7 is equal to -3. If you hit such a point, that lets you know that the visual representation of what you are working on looks something like this. You have two parallel lines, and the area of solutions do not overlap each other. Now let's walk through an example. Find the solutions by graphing the system of inequalities. Inequality A, we have x plus y is greater than 3. Inequality B, we have x minus y is less than or equal to 2. So how do we find the area of solutions? So step 1, isolate y on the left side of each inequality. So we'll first take a look at inequality A. X plus y is greater than 3. We want to isolate y on this side, so we'll subtract x from both sides, leaving us with y is greater than -x plus 3. So we'll change inequality A to y is greater than -x plus 3. You'll see why we do this in a second. It'll make it much easier to draw the lines that these expressions represent and to find the area of solutions. So this expression here, y is greater than -x plus 3, is equivalent or the same as x plus y is greater than 3. So we'll change this expression to this expression. We'll now repeat that process for inequality B. X minus y is less than or equal to 2. We'll start by subtracting x from both sides, leaving us with -y is less than or equal to -x plus 2. And now to negate the coefficient -1, you'll want to divide both sides by -1. When you divide or multiply both sides of an inequality by a negative number, you'll want to reverse the inequality. So we switch it from less than to greater than. When we divide both sides by -1, we get -y divided by -1 is y. We reverse less than to greater than and keep the equal to. -x divided by -1 is x. And +2 divided by -1 is -2. So inequality B, x minus y is less than or equal to 2, is equivalent to y is greater than or equal to x minus 2. So we'll switch this inequality with this one. This will make it easier now for us to figure out a few points on each line for these inequalities, and then use our greater than and greater than or equal to inequality signs to figure out what lines these expressions represent and the solutions for each expression. So step 2, we want to change inequality A to an equation. So we simply change this greater than sign to an equal sign. And now we have the line that represents that inequality. Y is equal to negative x plus 3. In step 3, we can record 3 xy values for equation A in a value table. So since we'll be sketching these lines in a coordinate plane, I am always going to use -1, 0, and 1 for our x values whenever possible. That way we get the points closest to the origin and sketch our lines closest to there. So for this line, y is equal to negative x plus 3. We'll plug in -1 for x and see what our y value becomes. So y is equal to -1 times -1 plus 3. -1 times -1 is positive 1. 1 plus 3 would give us 4. So along this line, when x is -1, y is 4. So that's 1 point on that line. We repeat this for where x is 0. -1 times 0 is 0. Plus 3 would give us 3 for our y. So when x is 0, y is 3. So 0, 3 is another coordinate on this line. And now we find one more point along this line when the x coordinate is 1, giving us y is equal to -1 times 1, which is -1. -1 plus 3 would give us positive 2. So 1, 2 is a third coordinate along this line. So now we'll put this value table to the side and repeat this process for inequality B so that we're able to sketch this line as well. So step 4, change inequality B to an equation. So we change our inequality sign to an equal sign. And now step 5, we want to record 3 xy values for equation B in a value table. We'll plug in -1, 0, and positive 1 for x, and then we'll record the resulting y value. So when x is -1, we get y is equal to -1 minus 2, which is equal to -3. So when x is -1, y is -3. And now we plug in x is equal to 0. Y is equal to 0 minus 2, which should be equal to -2. So when x is equal to 0, y is equal to -2. And now for our third point, we'll plug in positive 1 for x, giving us y is equal to 1 minus 2, which is equal to -1. So 1, -1 is a third point on this line. And now for each inequality, we have 3 points along the line for the inequality. And we have the inequality signs that will let us know whether it's the points above or below those lines that are solutions to the inequality. But before we begin sketching these inequalities, we first want to find the point where these two lines intersect. So this is now where we'll use the substitution and/or elimination methods to find the vertex. So step 6, we want to add the equations together. When we do so, we have equation A is y is equal to -x plus 3. And inequality B becomes equation B, y is equal to x minus 2. If we add the two equations together, we're able to eliminate our x and to find the y value for this vertex where the two lines intersect, giving us y plus y, which is equal to 2y. -x plus x cancel each other out. And 3 plus -2 is equal to 3 minus 2, which is 1. Now to negate this coefficient of 2, you can divide both sides by 2, leaving you with y is equal to 1 divided by 2, which is equal to 1/2, or 0.5. And now that we've found the y value for the vertex, we can now substitute y into either equation A or B, and then solve for x. So if you plug it into equation A here, you'll get 0.5, 1/2, is equal to negative x plus 3. And now you'll subtract 3 from both sides. 1/2 minus 3 would give you negative 2.5, or negative 2.5, is equal to negative x. You'll divide both sides by negative 1, leaving you with x is equal to negative 2.5 divided by negative 1, which is positive 2.5. So you get x is equal to 2.5 when you plug in y is equal to 1/2 into equation A. If you chose to plug it into equation B, you would get x is equal to 2.5 as well. So 0.5 is equal to x minus 2. So you'll start by adding 2 to both sides, leaving you with x is equal to 1/2 plus 2, which is 2.5. So we see that the vertex for inequality A and B is 2.5, 1/2. So now that we know the vertex and we've created value tables with 3 points for each line, we can now plot the vertex and sketch both lines. So step 10, we want to plot the vertex, the point where the two lines cross, positive 2.5 along the x and positive 1/2 along the y. So you sketch out a coordinate plane and you plot the point at 2.5 along the x and positive 1/2 along the y. And now you go back to the value table you created for equation A. In step 11, you plot the points from the value table in the coordinate plane. So the first point is negative 1 along the x and positive 4 along the y. The next point is 0, 3. And the third point is positive 1, positive 2. So now that we have the points that will allow us to sketch equation A, step 12, draw a dotted line through the points to create equation A, or line A. And it is dotted since in our inequality is greater than but not equal to. But before we shade the area that represents the solutions for inequality A, we're next going to sketch the line for equation B. So step 13, plot the points from the value table of equation B. So the first point is negative 1, negative 3. So you go to your coordinate plane and plot the point. The next point is 0, negative 2. So you plot the point. And the third point is positive 1, negative 1. Plot the point. And now you have the 3 points that will allow you to sketch equation B onto the coordinate plane. So step 14, draw a line through the points. And it is a solid line since inequality B is greater than or equal to. So the solutions are included on the line. In inequality A, they are not included along the line. And now that we have the sketch for both lines, we can now shade the areas that represent the solutions for each individual inequality. We want to shade the area above, greater than, above inequality A. So you go to the line for equation A and you shade the area above that line. And now for our second line, step 16, we shade the area above inequality B. So you go to the line for equation B, greater than is above it, so you shade the area above that line. So above inequality A and above inequality B would be this area right here. And then the solutions would continue, making this an unbounded or open system. So that is how you would go about finding the solutions to a 2x2 system of inequalities by graphing the inequalities. Let's now have you try a few practice questions. Find the solutions by graphing the system of inequalities. Question number 1. Inequality A, 2x minus 5y is greater than 10. And inequality B, x is greater than 3. Question number 2. Inequality A is negative x plus y is less than 3. Inequality B is 2x plus y is less than 0. In question number 3, inequality A is 4x plus y is less than 3. And inequality B is y is greater than 2x plus 6. Pause the video, answer these questions, and then press play when you are ready to begin. Question number 1. Inequality A, we have 2x minus 5y is greater than or equal to 10. In inequality B, x is greater than 3. So since we only have one variable here, step 1 will isolate y on the left side of inequality A, since we won't have to do it for B here, there's no y. So 2x minus 5y, we'll start by subtracting 2x from both sides, leaving us with negative 5y is greater than or equal to negative 2x plus 10. To cancel out this coefficient of negative 5, we'll divide both sides by negative 5. And since we're dividing by a negative number, we'll reverse the greater than to less than, leaving us with y is less than or equal to. Negative 2 divided by negative 5 would give us positive 2 over 5. We have 2x, so it's 2x over 5. 10 divided by negative 5 is equal to negative 2. And it'll make it easier when we're plugging in values for x if we change this fraction to decimal form. 2 divided by 5 is equivalent to 0.4. So we'll rewrite inequality A as that. So now, step 2, change inequality A to an equation. This way we can find 3 points along the line. So we get y is equal to 0.4x minus 2. In step 3, record 3 xy values for equation A in a value table. So we'll plug in negative 1, 0, and 1 for x and record the corresponding y values. So when x is negative 1, we get 0.4 times negative 1, which is negative 0.4 minus 2. Negative 0.4 minus 2 is negative 2.4. So when x is negative 1, y is equal to negative 2.4. So that's the first point in our value table here. Now we'll plug in x is equal to 0, and that would give us 0.4 times 0, which is 0. 0 minus 2 is equal to negative 2. So our second point, x is 0, y is negative 2. And now we'll plug in 1 for x, giving us 0.4 times 1, which is 0.4, minus 2. 0.4 minus 2 is equal to negative 1.6. So when x is positive 1, y is negative 1.6. So now that we have 3 points for equation A, we can create a value table for equation B. So step 4, change inequality B to an equation. So we change the inequality sign to an equal sign, giving us x is equal to 3. So in our value table, all of the x values will be 3. So we won't be changing the x from negative 1 to 0 to 1. So instead, we'll change our y to negative 1, 0, and 1. So our value table for equation B is 3, negative 1, 3, 0, and 3, positive 1. So this would be a straight vertical line going up and down where x is equal to 3 on the x-axis. So now that we have our value tables, we'll be able to sketch the lines for each inequality, but we first want to find the vertex where these two lines cross. So step 6, substitute x into equation A. So equation B is x is equal to 3. So since we know this, we can plug that in to A here, giving us y is equal to 0.4 times 3, which would be 1.2, minus 2 would give us negative 0.8 as our y coordinate for the vertex. And now that we know the y value, we know the vertex for A and B is where x is 3. Since that's the only x value where this line exists, it's a straight line up and down where x is 3. And it crosses at negative 0.8. So we have the vertex where the two lines cross, and we have value tables for each line, which will allow us to sketch each line. So now, step 8, we want to plot the vertex at 3, negative 0.8. So we go to 3 along the x-axis and down to negative 0.8. We plot the point. And now step 9, plot the points from the value table of equation A that we did a moment ago. So the first point is negative 1, negative 2.4. So we plot the point. The second point is 0, negative 2. Plot the point. The third value is 1, negative 1.6. So we plot the point. And now we have the 3 points that will allow us to sketch this line here. So step 10, draw a line through the points. And it's a line since we have less than or equal to. The equal to lets us know that it should be a solid line instead of a dotted line. So this line is for inequality A. Now let's repeat the process for B. So step 11, plot the points from the value table of equation B. So we plot the 3 points. So the first one is 3, negative 1. The second one is 3, 0. And the third point is 3, positive 1. And now with these 3 points, we'll be able to sketch our line for B. So step 12, draw a dotted line through the points. So now we have the 2 lines for each inequality. So now we just need to shade in our area. So step 13, shade the area below inequality A. It's below since our inequality sign is less than. So we shade in the area below the line for A. And now step 14, shade the area to the right of inequality B. It's a straight line up and down, and it's greater than. On the x-axis, the values go from 3 to 4 to 5 to 6 and so on. So they get greater to the right. So we shade the points to the right. And when we do so, we see the overlapping area below A and to the right of B is here. So this would be the answer to question number 1. So let's have a look at question number 2. Inequality A, negative x plus y is less than or equal to 3. Inequality B, 2x plus y is less than 0. So step 1, isolate y on the left side of each inequality. So starting with A, we want to add x to both sides, giving us y is less than or equal to x plus 3. So we'll rewrite inequality A with this expression. And now we'll rearrange inequality B. So since we want to isolate y on the left, we'll start by subtracting 2x from both sides, leaving us with y is less than negative 2x plus 0, which is the same as negative 2x. So we rewrite inequality B with y is less than negative 2x. And now we can create value tables for each line and then sketch each line. Step 2, change inequality A to an equation. So we change less than or equal to an equal sign. And now we want to plug in negative 1, 0, and positive 1 for x, and then write down the corresponding y values. So when x is negative 1, we get y is equal to negative 1 plus 3, which is positive 2. So that's the first point in this value table. X is negative 1, y is 2. We then plug in 0 for x, giving us y is equal to 0 plus 3, which is equal to 3. So that becomes the second point in the value table for equation A. And now we plug in positive 1 for x, giving us y is equal to 1 plus 3, which is 4. So the third point in this value table is x is 1, y is 4. And now we want to repeat this process for B. So step 4, change inequality B to an equation. So you change the less than sign to an equal sign, giving us y is equal to negative 2x. And now step 5, record 3 xy values for equation B in a value table. So we first plug in negative 1 for x, and we get y is equal to negative 2 times negative 1, which is positive 2. So the first point in the value table is negative 1, 2. We then plug in 0 for x, giving us y is equal to negative 2 times 0, which is 0. So when x is 0, y is 0. And now we plug in positive 1 for x. And when x is 1, we get y is equal to negative 2 times 1, which is negative 2. So 1, negative 2 is the third point in this value table. And now we can find the vertex where these two lines cross. So we'll write out both equations. Y is equal to x plus 3, and y is equal to negative 2x. And since we cannot eliminate the x's by adding or subtracting these two, we'll focus on the y's. And since we have y and y, if we subtract equation B from equation A, we'll cancel out our y's. So we'll solve for x first. So y minus y gives us 0. X minus negative 2 is x plus positive 2x, which gives us positive 3x, plus 3, or 3 minus 0 is 3. So now step 7, solve for x. So we want to subtract 3 from both sides, giving us negative 3 is equal to 3x. So we divide both sides by 3, and that gives us x is equal to negative 3 divided by 3, which is negative 1. So now that we've found the x value, we can now substitute x into either equation A or B to solve for y. So we'll start by plugging it into equation A in case that's the one you chose. So you get y is equal to negative 1 plus 3, which is equal to 2. So the vertex is where x is negative 1 and y is 2. Also could have plugged in negative 1 to equation B, and that would also give you y is equal to positive 2. Negative 2 times negative 1 gives you 2. So the vertex for A and B is where x is negative 1 and y is 2. So now that we know the vertex, we can plot the vertex where x is negative 1 and y is positive 2 in a coordinate plane. So we plot the point. And now, step 11, we plot the points from the value table of equation A. So you go back to that value table in your notes. And our first point is negative 1, 2. So it's the same as the vertex. The second point is 0, positive 3. And the third point is positive 1, positive 4. So now that we've plot the points, we can see where the sketch for this line will be. So step 12, draw a line through the points. So this is the line for inequality A. And it's a solid line since it's or equal to. Step 13, plot the points from the value table of equation B. So you go back to that value table in your notes. The first point is the vertex, negative 1, positive 2. The second point is the origin, 0, 0. And the third point is positive 1, negative 2. So these 3 points allow us to draw the line for inequality B. So step 14, draw a dotted line through the points. So now we have the 2 lines for our inequalities. Now step 15, shade the area below inequality A. We're shading the area below since its y is less than. So it's the points below that line. So we shade that area. And now step 16, shade the area below inequality B. We're shading the area below that line since it's less than as well. So we shade those points in. And we see the overlapping area, or the area of solutions, are the points between the lines here. So the solutions for question number 2 would be these. So that is the answer to question number 2. Let's now have a look at question number 3. Inequality A, we have 4x plus y is less than 3. Inequality B, we have y is greater than 2x plus 6. Step 1, isolate y on the left side of inequality A. We won't have to do anything to B since we already have y by itself on the left side. So for A, we want to subtract 4x from both sides, giving us y is less than negative 4x plus 3. So we'll rewrite inequality A this way instead. And now we can create value tables for A and B. So step 2, change inequality A to an equation. So we change the inequality sign to an equal sign. And now step 3, record 3 xy values for equation A in a value table. So when x is negative 1, y is negative 4 times negative 1, which is positive 4. 4 plus 3 is equal to 7. So when x is negative 1, y is 7. We then plug in 0 for x, giving us negative 4 times 0, which is 0. 0 plus 3 is equal to 3. So the second point in the value table is 0, 3. The third point, when x is positive 1, y is equal to negative 4 times 1, which is negative 4. Negative 4 plus 3 is negative 1. So when x is 1, y is negative 1. So this is our value table for A, and we repeat the process for B. So step 4, change inequality B to an equation. In step 5, record 3 xy values for equation B in a value table. So when x is negative 1, y is equal to 2 times negative 1, which is negative 2. Negative 2 plus 6 is positive 4. So the first point is x is negative 1, y is 4. Our second point, where x is 0, we get y is equal to 2 times 0, which is 0. 0 plus 6 is equal to 6. So our second point in this value table is where x is 0 and y is 6. And now for our third point, we plug in x is positive 1, showing us y is equal to 2 times 1, which is 2, plus 6 would give us y is equal to 8. So when x is 1, y is equal to 8. And now we have a value table for both A and B. So now we want to find the vertex where these two lines cross. So we write the equations for both A and B. And since our x's cannot cancel each other out by adding or subtracting the equation, we'll focus on canceling out our y's. We can do y minus y to cancel out our y's. So step 6 is to subtract equation B from equation A, giving us y minus y, which is 0. Negative 4x minus 2x gives us negative 6x. And 3 minus 6 equals negative 3. And now that we've gotten rid of our y variable, we can solve for the x. So we'll start by adding 3 to both sides, giving us 3 is equal to negative 6x. To get rid of the coefficient, negative 6, we can divide both sides by negative 6, giving us x is equal to 3 divided by negative 6, which is x is equal to negative 1/2, or negative 0.5. So this is the x coordinate for the vertex. So now step 8, we can substitute this x value into either equation A or B. And then step 9, we can solve for the y coordinate of the vertex. So if we plugged in x into equation A, we would get negative 4 times negative 1/2, which is positive 2. 2 plus 3 is equal to 5. So we see y is equal to 5. Or you could have plugged in negative 1/2 into B, and we get y is equal to 5 as well. So 2 times -1/2 is -1, plus 6 would give you y is equal to 5. So in either case, we see that the vertex of A and B is where x is -1/2 and y is +5. So now that we know the vertex and we have the value tables for A and B, step 10, we want to plot the vertex. So we'll go to -1/2 along the x and up to +5 along the y. And then we plot the point. Step 11, plot the points from the value table of equation A. So go back to the value table for A in your notes. And the first point is -1, 7. Plot the point. The second point is 0, 3. Plot the point. And the third point is +1, -1. Plot the point. And with these 3 points now, we can now sketch A. So step 12, draw a dotted line through the points. And it's dotted since it's less than but not equal to. And now we want to repeat this for B. So step 13, plot the points from the value table of equation B. The first point is -1, 4. The second point is 0, 6. And the third point is 1, 8. And now with these 3 points, we can sketch B. So step 14, draw a dotted line through the points. And it's dotted since it's greater than but not equal to. And now that we have the lines for both A and B, step 15, shade the area below inequality A. We're shading the area below since we have less than. So we go to A and shade the points to the left or below that line. And now step 16, shade the area above inequality B since we have greater than. So you go to B, sketch the points above. Here we see the overlapping area, or the area of solutions, are the points between the lines here. So this would be the answer to question number 3. So that is how you go about solving 2x2 systems of inequalities. Let's now wrap up the chapter by discussing bounded systems. So the area of solutions is considered open or unbounded if there are an infinite number of solutions. But if you introduce a third inequality and now close off the open-ended side, you have a closed or bounded set. So the area of solutions is considered closed or bounded if there are a finite number of solutions. Only the points within these 3 lines in the shaded area are the solutions to this system. So a bounded set is the overlap of solutions for all 3 inequalities, A, B, and C. So for A, it must be the points greater than or to the right of this line. For B, this line, it's the points greater than. And for C, it's the points less than. So that is how you wound up with the bounded set in here. So we'll create one from scratch when we walk through an example in a moment. But first, let's discuss when we have no set for our system. If the areas of solutions for all 3 inequalities do not overlap, then there is no set of solutions. So 2 overlapping areas will not do it. We need all 3 to overlap. So let's say we had inequalities A, B, and C, but let's say B and C are parallel. If that is the case, then there's a chance that we will end up with an empty set. So if the solutions to the left of this line or above this line solve B, and the points below C solve C, then it doesn't matter if the points to the left of A or to the right of A are looked at. We're only going to have areas where 1 or 2 of the solutions can be found, but not all 3. So in this space here, those would be the solutions to only A. Here, the points to A and B overlap, but not C. And here, the points to A and C overlap, but not B. And if we go back and look at the points less than A, here we have the points that overlap A and B but not C. And here we have the points that overlap A and C but not B and C. So B and C never overlap. Doesn't matter if we're looking at the points less than A or greater than A. And thus, for this system, we would have no solutions. So let's walk through an example from the beginning. You'll be asked to find the solutions by graphing the system of inequalities. Inequality A, x is less than 4. Inequality B, y minus x is greater than or equal to 1. Inequality C, y minus 5x is less than negative 2. So the process for graphing this system will be similar to a 2x2 system. So step 1, isolate y on the left side of inequalities B and C. There's no y in A, so we'll skip A for now. So for B, we'll start by adding x to both sides, giving us y is greater than or equal to x plus 1. So we'll write inequality B with this expression. And we'll repeat the process for C. So we'll add 5x to both sides, giving us y is less than 5x minus 2. So we'll rewrite C with this expression. And now we want to create value tables for A, B, and C so that we can sketch all 3 lines. So we'll start with A. Step 2, change inequality A to an equation. So we change the less than sign to an equal sign. And since x is always going to be equal to 4, in the value table, x will always be 4. So we'll change y from negative 1 to 0 to positive 1. So the 3 points in this value table are 4, negative 1, 4, 0, and 4, positive 1, which will be a vertical line where x is 4. And now we want to create a value table for B. So step 4, change inequality B to an equation. We change the greater than or equal to sign to an equal sign. And now we have y is equal to x plus 1. So we can create a value table for equation B. So when x is negative 1, y is equal to negative 1 plus 1, which is 0. So the first point in the value table is x is negative 1 and y is 0. When x is 0, y is equal to 0 plus 1, which is 1. So the second point in the value table is 0, 1. And when x is positive 1, y is 1 plus 1, which is 2. So 1, 2 is the third point in the value table. You then put that value table to the side and create a value table for C now. So step 6, change inequality C to an equation. So we change the less than sign to an equal sign. And now step 7, record 3 xy values for equation C in a value table. So when x is negative 1, y is 5 times negative 1, which is negative 5. Negative 5 minus 2 is negative 7. So negative 1, negative 7 is the first point in the value table. When x is 0, y is 5 times 0, which is 0. 0 minus 2 is negative 2. So when x is 0, y is negative 2. And the third point, when x is positive 1, y is 5 times 1, which is 5, minus 2 gives us 3. So the third point is x is 1, y is 3. So now that we have value tables for A, B, and C, we'll be able to sketch each of the lines. But we first want to find the 3 vertices before we sketch the lines. So these are the 3 places where these 3 lines will cross each other. So we'll have to find the vertex of A and B, and then we'll find the vertex of A and C, and then we'll find the vertex of B and C. So it's the same process, just 3 different times. So don't be overwhelmed by the number of steps that it winds up taking to complete this question. So step 8, substitute x into equation B. So we're finding the vertex of A and B, In A, equation A is x is equal to 4. So we plug in that x into B here, giving us y is equal to 4 plus 1, which is equal to 5. So when x is 4, y is 5, so that's the vertex for A and B. Now we want to find the vertex of A and C. So since x is equal to 4, we'll substitute x into C here and then solve for y, giving us 5 times 4, which is 20. 20 minus 2 is 18. So where x is 4 and y is 18, that's where A and C cross. So now we have 2 of the vertices. And now for the last vertex, we want to do B and C. So we want to subtract equation C from equation B and then solve for x. So we have y is equal to x plus 1 and y is equal to 5x minus 2. When we subtract them, we get y minus y, which is 0. X minus 5x is negative 4x. 1 minus negative 2 is positive 3. And now we can solve for x. So we'll subtract 3 from both sides, giving us negative 3 is equal to negative 4x. And now to negate the coefficient negative 4, we divide both sides by negative 4, giving us x is equal to 3/4 or 0.75. So now that we know the x coordinate for the vertex where B and C cross, we can now substitute x into either equation B or C and then solve for y. So if you plug this into B, you would get 0.75 plus 1, which is y is equal to 1.75. Or you could have plugged it into C, which should give you 5 times 0.75, which is 3.75. And then 3.75 minus 2 is equal to 1.75 as well. So the vertex for BC is where x is 0.75 and y is 1.75. So now we have all 3 vertices where the lines cross each other, and we have a value table for all 3 lines, so we can sketch A, B, and C. So now we can go ahead and begin to graph. So step 16, plot the vertices. So starting with AB, the first point is where x is 4 and y is 5. Plot the point. For vertex AC, it is where x is 4 and y is 18. Plot the point. And for vertex BC, it's where x is 0.75 and y is 1.75, so we plot the point. And now step 17, plot the points from the value table of equation A. So the first point is 4, negative 1. Plot the point. The second point is 4, 0. And the third point is 4, 1. So now with these 3 points, we can sketch the line for A. So we draw a dotted line through the points. And now step 19, plot the points from the value table of equation B. So the first point is negative 1, 0. The second point is 0, 1. And the third point is 1, 2. And now with these 3 points, you can sketch the solid line for B. So step 20, draw a line through the points. And it's solid since it's or equal to. And now step 21, plot the points from the value table of equation C. So the first point is negative 1, negative 7. Plot the point. The second point is 0, negative 2. And the third point is 1, 3. And now with these 3 points, we'll be able to sketch C. So step 22, draw a dotted line through the points. And it's dotted since it's less than but not equal to. And now we can shade the areas for each respective inequality. So step 23, shade the area to the left of inequality A. So inequality A is here, We shade the area to the left of it since we have less than. And now for B, step 24, shade the area above inequality B. So we go to B, it's greater than, so the solutions will be above this line. So we shade the points above that line. It'll continue in this direction. And now step 25, shade the area below inequality C. So you go to C here, and since it's less than, you shade the points below that line. And once you've shaded all three of those areas, you see the only area where all three overlap is on the inner part of these 3 points. So this would be the solution to this system. All right, so this is what we call a bounded or closed system of inequalities. And this is how you would find the solutions by graphing the system. Let's wrap up the chapter by having you complete a few practice questions. Find the solutions by graphing the system of inequalities. Question number 1, inequality A, x is less than 5. Inequality B, y plus 2x is greater than or equal to 6. Inequality C, y minus x is less than 3. Question number 2, inequality A, x is less than 2. Inequality B, y minus 3x is less than 1. And inequality C, y plus 2x is greater than or equal to negative 3. Pause the video, answer these questions, and then press play when you are ready to begin. Question number 1, step 1, isolate y on the left side of inequalities B and C. So for B, we have y plus 2x is greater than or equal to 6. And we'll subtract 2x from both sides, giving us y is greater than or equal to negative 2x plus 6. So we'll write inequality B with this expression here. And we'll repeat this process for C. Y minus x is less than 3. We'll add x to both sides, giving us y is less than x plus 3. So we'll write inequality C with this expression here. And now we want to create value tables for A, B, and C. So step 2, change inequality A to an equation. So that would be x is equal to 5. And now step 3, record 3 xy values for equation A in a value table. So since x is always going to be equal to 5, all 3 points x will be 5. So we plug in negative 1, 0, and 1, since this line will exist at all 3 of these y values. So this would be the value table for A. And now we want to create a value table for B. So step 4, change inequality B to an equation. So we change greater than or equal to equal to. And now we plug in negative 1 for x, and we see y is equal to negative 2 times negative 1, which is positive 2, plus 6, which is 8. So the first point in the value table is negative 1, 8. When x is 0, we get y is equal to negative 2 times 0, which is 0, plus 6 gives us 6. So the second point in the value table is 0, 6. And when x is positive 1, we get negative 2 times 1, which is negative 2, plus 6 is positive 4. So the third point in the value table is 1, 4. And now that we have a value table for B, we want to create a value table for C. So step 6, change inequality C to an equation. So we change the less than sign to equal to. And now we plug in negative 1 for x, showing us y is equal to negative 1 plus 3, which is positive 2. So the first point in the value table is negative 1, 2. The second point, When x is 0, y is 0 plus 3, which is 3. So 0, 3 is the second point in the value table. And when x is 1, y is equal to 1 plus 3, which is 4. So 1, 4 is the third point in this value table. And now that we have the value tables for A, B, and C, we can sketch all three of those lines. But before we do that, we want to find the three vertices where these three lines cross. So we want to find where A and B cross each other. We want to find where A and C cross each other. And then we want to find where B and C cross each other. So for A and B, equation A is x is equal to 5. So we can substitute x into equation B here and then solve for y, step 9, giving us negative 2 times 5, which is negative 10, plus 6. Negative 10 plus 6 is equal to negative 4. So when x is 5, y is equal to negative 4. So that's vertex AB. And now for AC, step 10, substitute x. X is equal to 5 into equation C, x plus 3, giving us y is equal to 5 plus 3, which is 8. So vertex AC is where x is 5 and y is 8. So now we have two of the vertices. And now we want to find the vertex where B and C cross each other. So we write those two equations out. And we'll subtract equation C from equation B so that we can cancel out our y's, giving us y minus y, which is 0. Negative 2x minus x is negative 3x, and 6 minus 3 is 3. To solve for x, we'll subtract 3 from both sides, giving us negative 3 is equal to negative 3x. And to get rid of the coefficient negative 3, we'll divide both sides by negative 3, giving us x is equal to negative 3 divided by negative 3, which is 1. And now that we know x, we can substitute x into either B or C. We're trying to find the vertex of BC, so we plug it back into either one of these. And then step 15 will allow us to solve for y. So if you choose to plug it into x into B, you would get negative 2 times 1, which is negative 2. Negative 2 plus 6 is positive 4. So the vertex for BC is 1, 4. You also could have plugged in x is 1 into C instead, giving you y is equal to 1 plus 3, which is 4. So you get the same vertex either way. So now we have all three vertices, AB, AC, and BC. And we have value tables for A, B, and C. So now we can plot our vertices, plot our lines, and then shade our areas to find the solutions. So step 16, plot the vertices. The first vertex for AB is 5, negative 4. The second vertex is AC at 5, positive 8. And the third vertex for BC is positive 1, positive 4. So we plot the vertices, and now we're ready to plot the points from the value table of A. And the first point is 5, negative 1. The second point is 5, 0. And the third point is 5, 1. And now with these 3 points, we can draw a dotted line to create the line for inequality A. And it's dotted since it's less than, but not equal to. And now step 19, we can plot the points from the value table of equation B. And the first point is negative 1, 8, 0, 6. And the third point is 1, 4. And now with these 3 points, we'll be able to sketch the line for inequality B. So step 20, draw a line through the points. And it's a solid line since in the inequality it's greater than or equal to. And now, step 21, plot the points from the value table of equation C. So the first point is negative 1, 2. The second point is 0, 3. And the third point is 1, 4. And now with these 3 points, we'll be able to sketch the line for C So draw a dotted line through the points. And it's dotted since it's less than but not equal to. And now we want to begin shading in the areas. So step 23, shade the area to the left of inequality A. It's a vertical line. In the inequality, the solutions are less than 5. So along the x-axis, less than or the smaller values are to the left. So we shade those points. Now step 24, shade the area above inequality B since it's greater than. So you go to B, and now you shade the points above that line. And now step 25, shade the area below inequality C since it's less than. So you go to C, and you shade the area below it. And we see the only area where all three overlap is the inner part of these 3 points. So this would be the solution to question number 1. Let's now wrap things up by taking a look at question number 2. Inequality A is x is less than 2. Inequality B, we have y minus 3x is less than 1. And inequality C, y plus 2x is greater than or equal to negative 3. So step 1, isolate y on the left side of inequalities B and C. So we'll start with B. And we'll add 3x to both sides, giving us y is less than 3x plus 1. So we'll rewrite inequality B with this expression. And now repeat the process for C. Y plus 2x is greater than or equal to negative 3. So we subtract 2x from both sides, and we'll rewrite inequality C with this expression. And now we want to create value tables for A, B, and C. So step 2, change inequality A to an equation. And since x is always going to be equal to 2, all 3 points in this value table, x will be equal to 2. And since it's a vertical line, we'll use negative 1, 0, and 1 for our y coordinates. So this is the value table for A. Now let's create a value table for B. So step 4, change inequality B to an equation. So change the less than sign to equal to. Now we plug in 3 values for x. So when x is negative 1, y is equal to 3 times negative 1, which is negative 3. Negative 3 plus 1 is negative 2. So when x is negative 1, y is negative 2. When x is 0, y is 3 times 0, which is 0, plus 1, which is 1. So when x is 0, y is 1. And our third point, when x is 1, y is equal to 3 times 1, which is 3, plus 1 is 4. So 1, 4 is the third value for this value table. And now we want to create a value table for C. So step 6, change inequality C to an equation. So we change greater than or equal to equal to. And now we plug in 3 values for x. So when x is negative 1, y is negative 2 times negative 1, which is 2. 2 minus 3 is negative 1. So when x is negative 1, y is negative 1. When x is 0, y is equal to negative 2 times 0, which is 0. 0 minus 3 is equal to negative 3. So when x is 0, y is negative 3. And when x is 1, y is negative 2 times 1, which is negative 2. Negative 2 minus 3 is negative 5. So 1, negative 5 is the last value in this value table. So now we have value tables for A, B, and C. So we want to find the vertices for AB, AC, and BC. So for AB, equation A lets us know x is equal to 2. So we could substitute 2 into equation B here. So that would give us y is equal to 3 times 2, which is 6, plus 1, which would give us 7. So y is equal to 7. So x is 2, y is 7 is the vertex for AB. Now we want to find the vertex for AC, so we want to substitute x into c here, giving us y is equal to negative 2 times 2, which is negative 4, minus 3, which will give you negative 7. So when x is 2, y is negative 7 for vertex AC. And now we want to find the vertex for BC, so we write those two equations out. And since we can't cancel out our x's with addition or subtraction, we'll focus on our y's. And we have positive y for both, so we'll subtract equation C from equation B, giving us y minus y, which is 0. 3 minus negative 2x is positive 5x. 1 minus negative 3 is positive 4. And now we'll subtract 4 from both sides, giving us negative 4 is equal to 5x. We'll divide both sides by 5, giving us x is equal to negative 4 over 5, or x is equal to negative 0.8. So now we know the x coordinate for this vertex, so we could substitute x into either equation B or C and then solve for y. So if we plug it into B here, we get 3 times negative 0.8, which is negative 2.4. Plus 1 would give you negative 1.4. So vertex BC is where x is negative 0.8 and y is negative 1.4. But you also could have plugged in negative 0.8 into C. So if you did that, you should get the same value for y. Negative 2 times negative 0.8 is positive 1.6. Minus 3 gives you negative 1.4 for your y. And with that, you have all three vertices where AB, AC, and BC cross each other, plus the value tables for A, B, and C. So let's start graphing these. So we'll start with the vertices. Step 16. So AB is where x is positive 2 and y is positive 7. AC is where x is positive 2 and y is negative 7. And BC is where x is negative 0.8 and y is negative 1.4. And now we can sketch the lines by using our value tables. So step 17, plot the points from the value table of equation A. Our first point is 2, negative 1. Our second point is 2, 0. And our third point is 2, 1. And with these 3 points, we can sketch A by drawing a dotted line through the points. And it's dotted since it's less than but not equal to. Step 19, plot the points from the value table of equation B. Our first point is negative 1, negative 2. Our second point is 0, 1. And our third point is 1, 4. And with these 3 points, we'll now be able to sketch B. So step 20, draw a dotted line through the points. And it's dotted since it's less than. And now, step 21, plot the points from the value table of equation C. So the first point is negative 1, negative 1. The second point is 0, negative 3. And the third point is 1, negative 5. And now we have the 3 points that will allow us to sketch C. So step 22, draw a line through the points. And now we can begin shading in the areas. So step 23, shade the area to the left of inequality A. The solutions are less than 2, so less than goes to the left. And now for B, shade the area below inequality B since it's less than. So you go to B and you shade in the points below that line. So we see A and B overlap here. And now step 25, shade the area above inequality C since it's greater than. So you go to C and you shade the points above that line. And the only place where all 3 solutions overlap is on the inner part of these 3 points. So this would be the solution to question number 2. And that wraps up this chapter on 2x2 systems. Should you have any follow-up questions, feel free to leave them in the comments section. Or you can contact a tutor in your neighborhood by visiting bookandtable.com or by downloading our app on the App Store. Peace.